I was reading a paper recently in Sigmod done by Slack on the challenges of melt data at scale. Melt being metrics, events, logs, and traces. I mean, it's definitely worth a read, but I feel like their approach, which combined Prometheus and Kafka and Secor and S3 and Spark, Elasticsearch and Presto, it's actually really complicated and is challenging because there are just a lot of piece parts that can break down. It's super expensive. And, there's a lot I need to keep in my head just to run a query to figure out what's going on and what's wrong. And, the core problem is that they're converting what is fundamentally a distributed systems problem, the desire to be able to see what's going on across a large number of nodes at scale in when there are faults in the environment, into a centralized problem by basically pushing data to a central location. Now, my personal view, I'm going to be kind of opinionated in this talk, is that that's fundamentally broken. Why? Because it's expensive. You're storing terabytes of data, pushing lots of traffic over a network, spending a lot of money to store it, but 99.99% of the time, you don't need it. And the bigger the data set is, the slower it is to analyze. So when you need it, it's slow, which disincentivizes you from storing a lot of data. It's also fragile because the time you need to observe your system is exactly the time when something's going on and something's wrong. And that's also often the time, for example, in a network event, where you stop getting telemetry. Finally, you have to be sort of this wizard at being able to predict what you're going to care about in the future. Because if there's some new event, you don't necessarily have a dashboard handy or a log handy that contains it. I remember at AWS once, one of the large-scale events I ran into was due to a BIOS upgrade by EC2. Now, there's no way I'm going to be logging or metricizing what version of the BIOS I'm at. For those sorts of things, you need to be able to execute a query at scale across your fleet and, see what's going on in the live environment. So at Shoreline, that's why we favor modeling the distributed system as a distributed system. You keep the data locally at the edge, you process it locally, and you invest in sophisticated data query processing to execute your commands in a parallel distributed manner across your data, real-time, fault-tolerant. So we have an agent that not only collects data, but analyzes it, takes action when necessary. The value of that is that it scales with your fleet size. It's using a tiny bit of resources on each node. More nodes, fine, it automatically scales with that. There's no networking latency because you don't have to push data to some central location. Since it's running at the edge, mean time to diagnose, mean time to repair for automated actions can be reduced to seconds. And finally, it's intrinsically fault tolerant because the edge node can take its local actions autonomously, even when the network's down or some piece of your observability infrastructure is down.